Okay, so tomorrow is your last test. The test is going to cover 2 lessons. It's 11.7 and 11.8. In lesson 11.7, we learned how to multiply and divide. We also learned how to rationalize the denominator. So on the test tomorrow, questions 1 through 8 are going to come from lesson 11.7. And then questions 9 through 12 are going to come from lesson 11.8, and that's what we just checked. So you'll have 4 questions from adding and subtracting, and then the first 8 are going to be the multiplying, the dividing, and the rationalizing. So let me go ahead and show you a few examples of what to expect tomorrow on the test. So again, from lesson 11, the first 8 questions, you'll have some that you're going to start out nice and easy like we did in the homework. So for example, you might get a question like 2 square root 5 times 3 square root 7. Remember, when we multiply radicals, you'll multiply outside numbers by outside. So 2 times 3 is 6, and then the 2 inside radicals. Now, if you could have broken down the square root of 35, you would, but we can't because notice the 2 numbers that we just multiplied to get, they are both prime, so that would be your simplified answer. Now, you may end up getting also questions to multiply where maybe the radicals are a little bit larger. So, for example, you might get 2 square root of 11 times 5 square root 44. Now, you could either choose to multiply 10 times or 2 times 5 and get 10 and 11 times 44 and get that really large number, or you could decide I'm going to factor this first and then see if I can make some pairs and get some perfect squares. Because essentially what we're doing here is multiplying the outside numbers, and then we're going to multiply all the radicals together. Now, if you realize 4 is a perfect square, you could pull that out, or you could factor it to 2 times 2 and make pairs. So let's go ahead and just make them all pairs. And then now notice I've got a pair of 11s, so 11 comes out. I've got a pair of 2s, a 2 comes out, and then I still had the 2 and the 5 out front. So then I would go ahead and multiply all of this together, and I could get 2 times 5 is 10, and then 2 times 11, 22, and then get 220. So potentially, if they end up multiplying and turning into perfect squares, you could get a whole number as your answer and no radicals. Or you could get a whole number and a radical. It's going to vary. So be able to multiply 2 radicals. Also be able to multiply 2 fraction radicals. So for example, if I gave you a question, let's say part of it's under the radical and part of it's not. 6 over the square root of 3 times 4 over the square root of 18. So if you're doing something like this, we would multiply top times top, bottom times bottom, and notice both of these are under the radical. Now you can again choose to do 18 times 3 and then simplify it for, let's see, 24 to 54. So you would get the square root of 54 and then have to break it down. So what might end up working better is if you break this down first. I could make this 3 times 6. Let's do that. And then I still have this one that I'm multiplying. I got a pair of 3s, so 3 comes out, 6 stays underneath. So now in this scenario, what's going to happen is you have 24 over 3 square root 6. I could simplify this stuff that's outside and make this 8 over square root 6. And now I have to rationalize. Remember, the rules are you can never leave a square root in the bottom of a fraction. So I'm going to multiply the top and the bottom by the square root of 6. This will give me 8 square root 6 over 6.
Sorry, I came to top drawer. Okay.
And then I can simplify 8 over 6, and I can make this a 3 and make this a 4, and then this would be 4 square root 6 over 3. Okay, so whatever comes out, if that fraction can be simplified, then you would simplify it. Okay, so be able to multiply fractions. Also be able to do one where the whole fraction is underneath the radical. So for example, let's see, 4, let's do this one, 4 over 5 times 10 over 36. So here what we can do is merge everything underneath one radical symbol. Remember, you could simplify the fractions before you multiply. Make that a 1, make that a 2, make that a 1, make that a 9. And then you get 2 over 9. Then you can pull it apart. And then you could square root the 9 and leave the square root of 2 in the top. So be able to work with fractions. Also, like we did in the notes where we just had something that had to be rationalized. So for example, if I give you 3 over the square root of 5 and I ask you to simplify that, all I'm looking for you to do is get rid of the radical. So you would rationalize. So multiply the top and the bottom by that square root of 5. And then this becomes 3 square root of 5. And again, we have a pair of 5s here, so the 5 comes out. So be able to just simplify and rationalize. Now, you may get 3 radicals that you're going to have to multiply. So for example, and we did this in the beginning of the homework, I believe question number 4 had 3 radicals. So for example, if you have 2 square root 5, 3 square root 5, 4 square root 9, and I ask you to multiply all 3 of those. Again, remember, you're multiplying outsides together. So I would be multiplying 2 times 3 times 4. And then all the radicals, if you could make some pairs, I've got a pair of 5s, so that comes out. And then I could also square root the 9 and just make that a 3. And now I'd have to go back and multiply those 5 numbers. Once I do that, I get 6, 20 times 3, 6 times 60, and I would get 360. So if everything comes out, then again, you could end up with a whole number. You'll also get questions where you're going to have to rationalize and there's something outside. So for example, number 28 that we did from the homework. Might get a question similar to that, where I have 15 square root 6 over the square root of 90. Now, what I can do here is I could simplify these two things that are under the radical, and I realize that I can divide 6 into 90, and it goes 15 times. So I could change this to 15 times square root 1 over square root 15. Now the square root of 1 is 1, so my numerator just becomes 15 times 1. So now I have 15 over the square root of 15. And again, you can't leave a radical on the bottom, so we have to rationalize again. So 15 times the square root of 15 over 15, because the pairs make it come out. They simplify. Final answer is just square root 15. So the majority of the test tomorrow is on the multiplying, dividing, and rationalizing, so the simplifying. And then the last 4 questions come from 11-8, and those are the adding and the subtracting of the rational or the radicals. So let's go ahead and examples of those. Now we'll start out nice and easy where all the radicals are the same. So for example, we might get 8 square root 15 minus 5 square root 15 plus 7 square root 15. Notice all the radicals are already the same, so I'm just going to go through and add and subtract the coefficients. So once I go straight across here, I would subtract 8 minus 15, I'm sorry, 8 minus 5, and get 3 root 15, and then finally add the 7 to the 3 and get 10 square root 15. And that would be your final answer. Now you're also going to get radicals that you're going to have to simplify before you can add and subtract. So for example, if you have a question like, say, number 10 from the homework last night, so negative 4 square root 75 plus 3 square root 147. So before I can even attempt to add and subtract these, I need to simplify the square root of 75 and the square root of 147. So the 75, I know I could break this down into 25 times 3. And then I can break down the 25 into 5 and 5. Notice I have a pair of 5s, so that 5 will come out. So I'm going to multiply negative 4 times 5, square root 3. So I end up with negative 20, square root 3. And now I have the 147. I'm going to divide 147 by 3 because I could already see my clue here that I've got the square root of 3. So that should be a signal that chances are 3 is going to go in here. I can also use my divisibility rules where I could add 1 plus 4 plus 7 and get 12. So that tells me 3 will divide in here evenly. So 3 will go into 14 4 times, subtract, and I get 49. So I'm going to break this down into 3 times 49. Break down the 49 into 7 and 7. Pair of 7s, one of them comes out, and the 3 stays behind. So now I have 21 square root 3, and now I can add them up. So negative 20 plus 21 is 1. So 1 square root 3. I don't need to show the 1. So my answer here is just the square root of 3. So you're going to have to break down some of the radicals. Also remember, you could have more than 1 square root in your answer. So for example, if I ask you to add 2 square root 5 plus 3 square root 7 minus square root 5 plus 5 square root 7, you can add these guys, or subtract actually, and just get square root 5, and then add these two and get 8 square root 7. So you can have 2 radicals in your answer. I cannot combine them because 5 and 7 are different radicals. And that's it. So 12 questions tomorrow. So again, if you've done the homework, the test looks very similar to your homework problems. Any questions?